Hi guys, in this video we'll try to take up some systems to check for its memory and causality. Let us take up first system, which is y of t is equal to g of t into x of t. First we'll check for its memory and then we'll go for causality. Okay. Now how when do we call a system has memory? We call that system has memory when its output y of t depends upon past or future value of the input x of t. Right? I repeat again, when its output y of t depends on past or future value of input x of t, then the system is called as it has memory. When does we call that system has no memory? System has no memory if its output y of t at every instant of time depends upon input x of t at same value of t of the output. Okay, so in this case you have to concentrate on input and output part of the system. Just ignore if you have any other coefficients. Okay, now if I put t is equal to 0, y of 0 is equal to x of 0, right? So output depends upon the input. If I put t is equal to 10, y of 10 is equal to g of 10 into x of 10. Now again output depends upon the input value, present input value, right? So whatever the value of t we put, present output depends upon present input value. If the present output of a system depends upon present input value, then what do we say? The system has no memory, right? So this system it has no memory. Why? Because its present output depends upon present input. Okay, input. Now what is the definition for causality? Let me define for non-causal. If the present output depends upon future input value, then the system is called as non-causal, right? Now y of t is equal to g of t into x of t. Does this depends upon future value? No, right? Here this current output depends upon current input value. I mean present output depends upon present input value, no? So therefore the system is causal, right? So it is causal system. Why? Because its present output depends on present input. Fine. We'll take up one more example. Y of t equal to t times x of t. Solution. First we'll check for memory and then we'll check for causality. Now for memory, y of t equal to t times x of t. Now whatever the value of t you put across the output, same value of t will come across the input, right? So present output depends upon present input. So if the present output of the system depends upon present input value, then we call it as system has no memory, no? So it has no memory. Why? Because present output depends on present input. Okay. Now what about causality? Y of t equal to t times x of t. The system is said to be causal if its present output y of t depends on past and or present input value. Here the present output depends upon present input value, therefore system is causal, right? So it is causal. Why? Because present output depends on present input. Present input. We'll take up one more problem. So y of t equal to e power x of t. Solution: memory and causal. Now, what about memory? E power x of t. If t is equal to 0, y of 0 is equal to x of 0, right? If t is equal to 10, y of 10 equal to x of 10. So whatever the value of t you put, the same value of t goes to output also. So present output depends upon present input value. So what is the conclusion? So it has no memory. So it has no memory. Why? Because present output depends on present input. Okay. So what about causal? Y of t equal to e power x of t. So present output depends upon present input value. So it is causal. Why? Because present output depends upon present input value. Okay. We'll take up one more. Y of t equal to g of t plus x of t. Solution. So first we'll check for memory and then causal. So what's your guess? Y of t equal to g of t plus x of t. What are the value of t I put? Same t follows here, right? Present output depends upon present input value. So it has no memory. Okay. So why? Because present output depends upon present input value. So what about causality of the system? Is it causal or non-causal? Yes, y of t equal to x of t. So present output depends upon present input value. So it is causal. Okay. Now we take up one more. Y of n is equal to x of 3n. So solution. First we'll check for memory. Then we'll check for causal. Okay. What's your guess? Does the output follows the input? No, right? If I put n equal to 10, what happens to input? It is 30. 3 times 10 is 30. So the output depends upon future input value. If the present output depends upon future input value, or the present output depends upon past input value, then we call it as system has memory. So in this case, present output depends upon future input value, therefore it has memory. So why? Because present output depends on future input value. Okay, what about causality? So it is non-causal, right? Why? Because what is the definition of non-causal? If the present output depends upon future input value, then the system is non-causal, no? So it is non-causal. Why? Because present output depends on future input value. Okay. So we'll take up one more. Y of t is equal to x of t by 2. Okay. Solution. We check for memory first and then causal. So what's your guess? So y of t is equal to x of t by 2. If I put t is equal to 10, y of 10 is equal to x of 5, right? So what do you mean by that? Present output depends upon past input value, correct now? So how did I say that? If this is 0, this is input x of t, and if this is output y of t, this is independent variable t, some random input and output. If I put y of t as 10, so this is my present output now, 10. Y of 10 depends upon what? X of 5. And where is x of 5? 5 is here. Okay. Now with respect to this dashed line, everything left hand side is actually past, and everything to the right hand side is future. Now present output depends upon past input value. Therefore it has memory. Why? Because present output depends on past input value. So what about causality? So y of t is equal to x of t by 2. Does this bit depends upon future? Yes, right? How? Because if I put t is equal to minus 10, what is y of minus 10? Y of minus 10 is x of minus 5. Okay, now present output depends upon future, no? Correct now? How is it? So if I just put this is x of t and this is y of t, this is t, y of minus 10 is here, y of minus 10 is equal to x of minus 5. Sorry, y of minus 10 is here and this is equal to x of minus 5. So now this is my reference point, current output, minus 10 is the current output. Now the current output depends upon, this is future and this is past, no, with respect to dashed line. So present output y of minus 10 is equal to future input x of minus 5. Therefore system is non-causal. Okay, so we'll take up one more. Y of t is equal to x of t square. So solution, memory and causal. So what is your guess? If I put y of 10, what is x of 100, right? So present output depends upon future input value. So system has memory. Right? And what about causality? If I put minus 2, t is equal to minus 2, what happens? Y of minus 2 is equal to x of 4, right? So present output, so y of minus 2 is here, is equal to x of 4. 4 is here. So present output depends upon future input value. So system is non-causal. Okay. I'll take one last problem. Y of t is equal to x of minus t. So solution, let's check for memory and then causal. Okay. So what is your guess? So depending upon what value of t I give, if I give t positive, this becomes negative. If I give t negative, this becomes positive. So whatever it is, present output for some values of t, present output depends upon past input value, and for some values of t, present output depends upon future input value. So therefore the system has memory, right? Let me give you an example. If t is equal to 2, what is y of 2? Y of 2 is x of minus 2, right? Now present output depends upon past input value, right? If I give t is equal to minus 2, what is y of minus 2? Y of minus 2 is x of 2. Now present output depends upon future input value, right? So in both the cases satisfies the definition of memory, so it has memory. Okay. What about causality? It is non-causal, right? Why? So from the definition of memory, see here, y of minus 2 is present output depends upon x of 2, future input value. Therefore, it has memory. Why? Because present output depends upon future input value. Now I'll give you some exercise, practice problems. You just try for its memory and causality. The first one, y of t is equal to n square x of n minus 1. Second system, y of t is equal to mod of x of t. And third one, y of n is equal to cos of x of n. Fourth one, y of t is equal to sine of 60 into x of t. And fifth one, y of t is equal to x of t minus t naught.